Okay, so in the previous video we have seen how to do a flowchart scheduling. We determine the sequence in which the jobs has to be scheduled based on Johnson's algorithm, and we determine what is the make span time, that is the total completion time of all the jobs in the particular batch. Now, so this is a table. This is more like a timetable where the start time and the end time of each job in a mission is given. If you want to see in a graphical representation of this timetable, that is known as Gantt chart. Okay, so Gantt chart is a type of bar chart where the x-axis will be the time period and the y-axis will be the resource. Okay, so in the y-axis you can either have the missions or the jobs. Okay, both can be done. If the y-axis represents the mission, it is known as mission Gantt chart, and if the y-axis represents job, it is known as job Gantt chart. Okay, so in case of flowchart scheduling, we ideally use mission Gantt chart. So in y-axis we have used mission. Okay, so whatever we have seen here, we are going to represent that as a graph, that is a bar type of bar chart using Gantt chart. Okay, so let us plot the time period. So the make span time is 76, right? So I plotted the time period from 0 to 76. Okay, the job 1 first enters the mission 1 from 0 to 4, right? So 0 to 4, draw the a rectangle from 0 to 4 and shade it, and inside it write job 1. Okay, so job 1 is being processed from time period 0 to 4 in mission 1. Okay, next the job 4 enters the mission 1 at 4th minute and comes out at the end of the 12th minute. Okay, so from 4 to 12, draw a rectangle, shade it and write 4 inside. So this is whatever you're writing inside, that is the job. You can also mark it as J4 to avoid the confusion, J1, J4. Okay, then from 12th minute to 24th minute, if you look at your timetable, that is 12th minute to 22nd minute, so 22nd minute, job 2 is being processed in mission 1. So like this, you plot each and every job that is being processed in mission 1. So in mission 1, it is being processed up to 70th minute. So up to 70th minute, it is being processed. Okay, then we are going to process in mission 2. So from 0 to 4, mission 2 is idle. So idle time is represented by a blank rectangle. If your rectangle is shaded, it means it is being utilized, and if it is blank, it means it is not being utilized. So in mission 2, the job 1 is being processed from time period 4 to 10. So 4 to 10, draw a rectangle, shade it and write J1 inside. Then from 10 to 12, okay, that's a 2 minutes idle gap, right? From a minute 10 to 12, it is remaining idle because the job 4, that is the next job 4, it enters the system, that is mission 2, only at the end of 12th minute. So from 10 to 12, the rectangle will be blank. This represents the idle time. Then the job 12, job 4, it has been a mission from 12th minute to 22nd minute. Okay, then from 24th minute to 36th minute, next job is being processed. Then from 36th minute to 46th mission, job 3 is being processed. Then from 46th minute to 52, the mission 2 is idle. Okay, so whatever we have found here, that is whatever we have written in the timetable format, we are just representing in the graphical format, and that is known as Gantt chart. Okay, so we have seen what is flowchart scheduling, and the objective of flowchart scheduling is to determine the optimal sequence in which the make span is minimized. Okay, so for that purpose we are using Johnson's algorithm, but this Johnson's algorithm is applicable only for 2 missions. Okay, you can have n different jobs, but you can have only a maximum of 2 missions. Okay, so extension to the Johnson's algorithm is provided. Okay, you can extend the proposed Johnson's algorithm if it satisfies a particular criteria. Okay, we have two criterias, and if any one of the criteria is satisfied, we can apply the extended Johnson's algorithm. Okay, we'll see that a criteria with an example. Okay, so I am going to apply the extended Johnson's algorithm for n jobs and 3 missions. Okay, so there are 5 jobs, and it requires processing in mission 1, followed by mission 2, and followed by mission 3. The processing time of each job in each mission is given. Okay, let us see the criteria. The first criteria is I have to find out what is the maximum processing time in mission 2. Okay, out of a given batch of jobs, what is the maximum processing time here? The maximum processing time is 10. Okay, next I have to find out what is the minimum processing time in mission 1. Okay, so in this column I have to find out what is minimum, and in this column I have to find out what is maximum. Okay, so whatever minimum value I found out, that should be greater than equal to whatever maximum value I have found here. Okay, that is the first criteria. Okay, if you go by that criteria, the minimum time is 10 and the maximum time here is 10. So 10 is greater than or equal to 10. Okay, so first criteria is satisfied. Okay, if you go by the second criteria, I have to find out what is the minimum processing time in the third column. And this minimum time should be greater than or equal to the maximum time which I found in the second column. Okay, so here the minimum is 8 and the maximum we found was 10. So here the criteria is not satisfied, that is 8 is not greater than or equal to 10. So this criteria is not satisfied. Okay, so out of these two criteria, if any one is satisfied, I can apply the extended Johnson's algorithm. Okay, so here the first criteria is satisfied, so obviously I can apply the Johnson's extended algorithm. Okay, so always make sure in the second column find out the maximum value, and in the first and third column find out the minimum value. Okay, the minimum value of finding out, it should be greater than the maximum value you have determined. If it is any one criteria is satisfied, you can apply the Johnson's algorithm. Okay, now I am going to convert this given problem into a hypothetical problem so that the Johnson's algorithm can be applied. Okay, so how I am going to do this? We know that the Johnson's algorithm is applied only when there is 2 missions, right? So I am going to determine a hypothetical mission, that is mission A, which includes the mission 1 and 2. Okay, and the second mission is going to be mission B, which includes mission 2 and mission 3. Okay, so what I am going to do is, I am going to consider a hypothetical mission A, which considers the mission 1 and 2 processing time. Then I am going to consider a hypothetical mission B that includes the mission 2 and mission 3's processing time. Okay, see. So job 1, hypothetical mission A, it is going to include 10 plus 10, 20, 10 plus 10, 20, and the mission B is going to be 10 plus 12, 22. Okay, then if you look at here, the second job, 12 plus 8, 20, 12 plus 8, 20, and 8 plus 20, 28. So like this, I am going to convert this 3 mission problem into a 2 mission hypothetical problem. So mission A will include mission 1 processing time and mission 2 processing time. Mission B is going to include mission 2 processing time and mission 3 processing time. Okay, now we are back to our Johnson's algorithm for 2 missions and n jobs. So in the same way we are going to find out the sequence. Okay, let us do the step. So there are 5 jobs. So draw 5 straight lines. 2, 3, 4, 5. Find out the minimum processing time. So the minimum processing time is 60. So that's a tie. You can break it randomly. So I'm going to choose job 4. Now I have to allocate the job 4 in the sequence, and this minimum processing time falls on the first mission. So I am allocating in the first available position. Strike out job 4. Next, the minimum time is 16. It's available in the second mission. So the corresponding job is allotted to the last available position. Strike out this job. Right. Next, the minimum time is 20. The corresponding job, it's available in the first mission. So I'm placing it the first available position. Strike that out. The next minimum time is 20. It's in mission 2. So allocate the job in the last available position. Strike it out. Okay. Again, that's a 20. It's available in the first mission. So you can have either this sequence, or if I have broken the tie, it can also be 1, 4, 1, 2, 3, 5. Okay. The make span time will be same if you use either of these two sequences. Okay. In the next video, I will tell you how to determine this timetable.